In section 1D, we're not working with square roots, but actually squared terms, and we're trying to solve the problem by taking square roots. Unlike some factoring problems where you might have a n squared and an n and a number, here we are just going to have an n squared and a number. So if we zoom into our first example here, you'll see we have negative n squared equals negative 59. Now you might be tempted to just start taking square roots. Before you do that, you want to make sure that the squared term is completely by itself. So if there's anything added or subtracted, you need to get rid of that. If there's anything multiplied, you need to divide that out. In this case, it's kind of subtle, but we have a negative 1 being multiplied by the n squared. So we need to multiply or divide both sides by negative 1 so we can get rid of that. So if we do that, then we end up with n squared equals positive 59. Now we can square root both sides, and when we do that, we're going to get n equals square root of 59. That's what we're used to doing. However, one of the things that's interesting about taking a square root, when you are undoing a square and you have applied the square root, you need to remember to write plus or minus before you do it, meaning that your answer is going to be positive or negative square root of 59. Reason is if you think of a number, let's say like negative 2, and you squared it, it becomes positive. So in this case, if you had n squared equals 4 and you want to know what the solution was, you have to square root both sides. You would need to say the positive or negative square root of 4, which would mean positive or negative 2. In this case, negative 2 works just as well as positive 2 would get you back to 4. So either of those answers would work. That's why we say positive or negative root 59. If you wanted to write it as n equals square root of 59 or negative square root of 59, this would be an acceptable answer. This is just a shortcut with that plus or minus symbol. Let's skip down to number 5, a little more complicated example. You'll see that we have a 2 multiplied by the x squared that we're going to have to get rid of, and a negative 4 here being subtracted. So first thing, you always want to go in the reverse order of operations. Our goal is to get this term alone first. So add 4 to both sides. So now 2x squared equals 182. Now that we have this term alone, we really want to just get the x squared isolated, so we're going to divide both sides by 2. And when we do that, we get x squared equals 91. And then our final step is to take that square root of both sides to get x alone. But when we do that, we remember we take the positive or negative square root. So x is equal to plus or minus the square root of 91. And now in the case of this one and the one above where we had square root of 59, neither of those happen to reduce. If we could reduce this, if 91 was had factors that we could break it down into, and we could pull out a perfect square, you would want to reduce it. So if it was, for example, the square root of 24, you would want to factor tree that down. And when you do that, you could pull out something. So you could write that as plus or minus 2 times the square root of 6. So this would be a better answer than leaving it plus or minus root 24. But in the case of these two, they're prime numbers, so we're okay.